This video will present a brief phase-by-phase summary of what happens to the big four elements during the cardiac cycle in each phase. I'm assuming in your watching this that you've watched video number 2, which is the illustrated version of the cardiac cycle. I honestly would encourage you to watch that a couple times before going through this and looking at the summary. You'll understand the summary better if you've seen the whole process. So, how to summarize? Let's begin with ventricular systole, and the first phase of ventricular systole is isovolumetric contraction. During isovolumetric contraction, the AV valves close due to increasing ventricular pressure. The semilunar valve remains closed because pressure is higher in the aorta than in the left ventricle. As I've already noted, ventricular pressure increases because the ventricular myocardium is contracting, and ventricular volume remains constant at end diastolic volume. Isovolumetric contraction leads to the second portion of systole, ventricular ejection. In this phase, the AV valve remains closed due to ventricular pressure being higher than atrial. The semilunar valve opens when ventricular pressure exceeds aortic pressure. Ventricular pressure first increases as a result of contraction, and even though the contraction continues, it eventually decreases late in ventricular ejection because of the decrease in volume. So as the ventricular volume decreases to end systolic volume, you'll see ventricular pressure decline. That leads us to ventricular diastole, relaxation of the ventricle, the first portion of which is isovolumetric relaxation. In this, the AV valve remains closed because ventricular pressure remains higher than atrial. Semilunar valve closes as soon as left ventricular pressure is less than aortic pressure. Ventricular pressure is decreasing because of the relaxation in the ventricle, but the fact that both valves are briefly closed means ventricular volume remains constant at end systolic volume. That leads to ventricular filling, beginning first with rapid filling and diastasis, in which the AV valve opens when ventricular pressure drops below atrial pressure. The semilunar valve stays closed because ventricular pressure is less than in the aorta. Ventricular pressure remains relatively constant because as blood moves in, the volume is increasing as the ventricle expands, but ventricular volume in terms of blood increases to approximately 70% of end diastolic volume due to the passive movement of blood from high to low pressure from the atrium to the ventricle. And then at that point, active filling occurs due to atrial systole. The atrium contracts. The AV valve is going to stay open, and the semilunar valve stays closed because the pressure relationships really don't change. Ventricular pressure does increase slightly from blood being squirted in by the atrial myocardium, and the ventricular volume will increase to end diastolic volume.